Hello everyone, and welcome to Unit 3, Lecture 2 on Tools to Conduct a Situation Analysis. Today you see me looking very professional, cooling off in a tributary of the Mara River in Kenya. And this basin will be one of the case studies shown in the upcoming Lecture 3 of Unit 3. You will have learned by now why it is so important to do a comprehensive situation analysis before moving too far forward into an eFlows program. There are many tools available to aid in the different aspects of conducting a situation analysis, and then some of the more useful and practical tools are going to be explained in this lecture. What tools can be used to make a situation analysis? There are many different tools that can help you to conduct a situation analysis. Depending on the complexity of your situation, you may be content with just conducting a literature review, a V-steep process, and a stakeholder analysis. This might be appropriate for a single project, but not necessarily for a whole basin scale eFlows process. And a more detailed DIPSA framework may be required, especially in complex situations. Viewing your system within a social ecological systems framework is also another good way to gain an understanding of the basin, and using tools such as GIS Mapping can also help you to really visualize the system. A literature review. Starting with a literature review helps to understand what information is readily available, either online or in the offices of the different departments that you're dealing with. And yes, you may have to go and get photocopies. Gathering this information allows for starting to build a library of background information on the eFlows process within the basin. And it's very valuable to understanding the context of the basin. It can also help you to identify the next stages of the situation analysis, where information might be lacking, or even which stakeholders you need to engage with. There are many different media types you can use, but caution should be taken on the reliability of information gathered, and some of it may be conflicting. In general, scientific literature that has been peer-reviewed is considered the most robust, but all information is valuable at this stage, so newspaper and social media are also other good sources of information. V-steep as a basin context tool. As mentioned in the Management Fundamentals lecture, understanding and taking into account the context of the basin where the eFlows process will take place is essential within any eFlows program. The V-steep process can help you to explicitly understand the context of the basin and forms part of the reading for these lectures. So you have values. These represent the way in which people and societies approach their day-to-day lives and what they consider important to them within the basin. You have the social situation. This is about the way that people interact, their norms, their social structures. You have technology, so tools and the knowledge and how to use them. The environmental, so the ecosystems contained within the basin. You have the economics, so the business and the financial, the trade, the monetary systems within the basin. And the political, so this is around the legal and the procedural context. So using a V-steep process combined with a literature review allows you to not only understand the basin better, but also identify stakeholders and areas where information is lacking or needs particular attention. Stakeholder analysis. Simply identifying different stakeholders and stakeholder groups is not adequate within a situation analysis. Additional analysis of stakeholders may include assessment of their interests, their influence, and their importance. This information can be collected in a stakeholder matrix, as is shown in the figure, and used to classify stakeholders in what is called an importance influence matrix. Some questions need to be considered in the assessment, and these include: what are the stakeholders' values within the system, and what are their expectations of the program? What are the likely benefits or disbenefits for the different stakeholders? What resources might the stakeholder be willing to mobilise to actually support the project? which stakeholder interests conflict with other stakeholder interests, and what are the general conflict within the basin that you're studying. Category 1 stakeholders have high importance but little influence. Examples will include resource-dependent communities, subsistence-based communities. As these groups will be the targets of your project, they will require special efforts to ensure that their needs are met and their participation is meaningful. They loosely fit in the partner type of involvement. Category 2 stakeholders will have high importance and high influence. Examples include governments or the donors, and these stakeholders should be closely involved throughout to ensure that their support and the project's success is maintained. These stakeholders loosely fit into the control type of involvement. Category 3 stakeholders have usually low importance but high influence. They're not the target of the program or project, but they can use their influence to facilitate it or derail it. Examples could be religious groups or other organisations. They need to be kept informed and their views need to be acknowledged so that they cultivate support and to avoid disruption and/or conflict. They loosely fit in the consult type of involvement. Category 4 stakeholders have low importance and low influence and are unlikely to be closely involved in the project. Examples include institutions of higher learning. They require no special participation strategies, although they could be informed in a general way of the different interventions and its results. These category fits loosely into the inform type of participation. Driver pressure state impact response models. So DIPSA is a useful way and a widely applied framework for analysing cause and effect relationships between human activities that impact the environment, the resulting environmental conditions, and the possible responses to improve these environmental conditions. In each stage of the process, indicators should be identified to enable monitoring of progress. Very elaborate versions of the framework are also available, which subdivide the causal chains into more detail. But for a situation analysis, keep it as simple as possible and just try and draw out and highlight the major cause and effect relationships. And this will help you to improve your understanding of the system. You have an example of this, one of the DIPSAs, in your reading. So DIPSA models analysing the situation, and here I am presenting an example. So DIPSA models, they should be used to elaborate the different drivers, pressures, resulting states, impacts, and the possible responses to the issues, both directly and indirectly, that are affecting the ecological conditions of the aquatic system. An in-depth analysis of the cause and effect relationships will likely reveal a very complex array of interactions which link to, but actually go beyond, the scope of the environmental flows project. But it's good to note them and have them. Recognition of these related processes is important for you're able to then set realistic goals for the environmental program and link it to larger efforts within the integrated natural resource management that's occurring in the basin. So Bayesian networks for understanding causal relationships between variables. This is an example of a DIPSA model being transformed into a Bayesian network model that includes risk probabilities, and it also assesses the impact of certain changes in the driver and pressure variables on the response variable, and it does it in a quantitative manner. This kind of tool may help you to visualize and quantify the potential impact of the different scenarios, but most importantly, it helps you to find and understand the relationships between the variables within the ecosystem. Social ecological systems framework. So water resource management, as discussed previously, always needs to be considered as part of a larger social ecological system. And McGuinness and Ostrom, in 2014, they propose an extensive list of measurable variables that can be used for assessing the sustainability of a social ecological system. Now, depending on the system and the research questions you want to answer, you can use a selection of these different variables to include in your sustainability analysis. This should be kept simple enough that it helps you to draw out these particular relationships between the different social and ecological components, but not overcomplicate things so that you have to spend a significant amount of time on it. GIS mapping. Mapping is a visual tool for situation analysis, where various layers, both the water-related and the other sectors, can be overlaid and analysed. And GIS mapping now is even more accessible with open source software like QGIS and mapping tools like OpenStreetMap. Google Earth is another example. This is very helpful for visualising the data and looking into the spatial and temporal aspects of the basin. So the take-home messages. Situation analysis is an essential step of any eFlows program. It allows for the context of which you want eFlows to be implemented in, to be well understood, and any challenges addressed from the start in an explicit and transparent manner. It should be extensive enough to draw out the relationships, and you can use the tools to do this, between the different social and ecological components, but not too complex that you get caught up in it. It should be really about identifying what are the relationships, social ecological relationships, what are the knowledge gaps, and which of the stakeholders need to be involved.